So we're finding the area, an integral that will represent the area under each of these curves, or of the shaded region for each of these curves. We've done the first one. The second one would be the integral from what to what?
C to D.
C to D. Of
Absolute value.
Okay. Well, suppose we didn't want to use an absolute value.
Negative g of x.
Negative g of x. Very good. So if you remember, when the region is below the x-axis, the integral is going to give you a negative value. So you have to multiply by -1 to make it positive. Good. All right, so next region. Whoa, we've got multiple functions here.
You have to subtract the integral of r to the x with s of the x, right?
I mean, that's
All right, well, let's do our limits first. This is the integral from what to what? E to f. All right. What minus what?
r minus s.
R minus s? Not, are you sure it's not s minus r?
Well, you do like 20 minus 10, not 10 minus 20.
You're correct. Yeah, okay. Yes, r minus s, it is. And the reason it is, if you think about it, yes?
Can you like just separate like the actual integrals?
You can, but you're not going to want to, because when we get into more and more of these, there's going to be so many integrals, it's easier to just put it together in one integral. But yes, you could. If you wrote the integral of r minus the integral of s, that would be fine. So the integral from e to f of the function r would give you this whole area, right? All the way down to the x-axis.
Yep.
The integral of the function s would give you this area, the space right here. So if we did this whole area minus the space, we get what's left. Does that make sense?
Yep.
Okay, good. All right, this one's tricky. First, what are the limits?
P to q.
P to q.
And then isn't it k plus h? Or negative k plus h?
H minus K. It's K negative K.
Is it h minus k or k minus h?
K minus H. H minus K.
It would be H minus K.
H is bigger.
Because it's negative K plus H. H minus K.
It's h minus k. I'm not writing the of x's, but that's okay.
Well, can't you just hold function out?
Yeah. Yes?
Why was it negative for number 2 but not number 4?
It is negative to number 4.
It is negative.
Because it's negative K plus H, because negative minus negative.
It's negative minus a negative. You do the k, if you want to think about the way you're thinking about it, this whole region here would be negative k, right? And then we need to subtract the space, which would be negative h. So you get negative k minus negative h, which is negative k plus h.
Okay.
Does that make sense? So it ends up being h minus k. Now, we can actually write a formula in general for this then, for area between any two curves. And here's your formula. In general, area is the integral from a to b. And let's just say that a and b represent the left and right endpoints of your interval. All right? Okay, so the integral from a to b of, I'm going to write it like this, top minus bottom dx. It's always the top function minus the bottom function. No matter where the x-axis is, it's the top function minus the bottom function. If you go back and look at the first couple,
It's just minus 0.
the top function is f, the bottom function is 0. So this would be f minus 0. For this region, the top function is 0, the bottom function is g, so your integral would be 0 minus g. For this one, top is r, bottom is s, r minus s. For the last one, top is h, bottom is k, you get h minus k.
That's good.
So it is always, no exception. It doesn't matter if the x-axis goes right through the region. No, with no exception, it is always the integral of top minus bottom. All right? Except there's an exception. Or there's no exception except for this exception. So
So the exception's gonna be there a lot, because
except when we decide to turn it sideways and integrate with respect to y. If we decide to turn the region sideways and integrate with respect to y, then instead of doing top minus bottom, we're going to do right minus left. So in this class, you'll see problems with both, and you're going to just get used to it, all right? So some problems will be presented vertically like this, with a function on top and a function on the bottom. Some problems might be presented with graphs that look like that. They wouldn't be functions, but with graphs, some weird function to the right and some weird thing to the left, and you would have to find an area going this way,
even though it's not functional.
okay? Even though it's not a function. Area of a region. Alrighty. So let's do some examples. Did I mention that this unit is all on area and volume?
And it says on the website.
So all we're doing for this unit is finding areas of regions and finding volumes of solids. So if you can think about it for a minute, finding an area of a curved space, curved region, is something that might come in handy from time to time. All right, the first thing I think of whenever I think of area of curved spaces, I always think of the map of the United States and all the different states.
Can we do that?
And you want to do like find the map of all 50, or the area of all 50 states? You would have to find a function to model all of those boundaries.
I bet I'm gonna look it up.
All right, so here we go. All right, find the area of the region bounded by y equals x squared and y equals 2x plus 3. I did do a project in this class years ago where we had to find a volume of a bunt cake, which was kind of fun. You had to sit there and like trace, everyone got a piece of bunt cake, and you had to trace the outline and then find a function to model the curve on the top. And usually it was just a bunch of functions put together, and then create like this spinning thing where you spin it around the center and get the volume. But the problem was I had some students who sat there and like drew every crumb on the bunt cake and had like 42 functions just for the top.
Oh my
And
goodness.
and then I had some students who said, oh no, my piece was shaped like that, right? And so, yeah, so it was funny because it ended up being a problem that took days for some students and 10 minutes for other students, because depending on how they traced their
And
bunt
answers were
cake.
similar?
Yeah, and the answers were pretty similar. So I stopped, and it was a pain because I had to bake all those cakes too. But anyway, let's see. All right, so here we go. So we have this region, y equals x squared and y equals 2x plus 3. You do not have to sketch a graph, but it helps. So I'm going to go ahead real quickly and just sketch what we're talking about. So we have y equals x squared and y equals 2x plus 3. Something like that.
Ish.
So we're talking about this region right there. That would be the region enclosed or bounded by those two graphs. The graphs become the boundaries of the region. All right, so What did they not give us in this problem? They did not tell us where to start and where to stop. So we know we have to start here and we know we have to stop here, but we don't have those values. How can we find those values? Yes, yes, and yes, yes. Those are the points of intersection, and in order to find the points of intersection, we're going to use our substitution and substitute this y with an x squared, and which is basically the same thing as setting the functions equal to each other. So everyone take a second and see if you can find the x values for the points of intersection. What's the first thing you do when you're solving a quadratic equation? Set it equal to 0. What's our favorite F word?
Fraction!
Factor.
Factor! There's so many to choose from, I know. All right. Did everyone get -1 and 3?
Yeah.
Good. So now we just write our setup. Area is the integral from -1 to 3. All right, we need to do top minus bottom. Looking at the picture, which function is on top? The line, right? And then the parabola is on the bottom? Okay, so we know visually, just by looking at it, that we can write the setup of 2x plus 3 minus x squared dx, top minus bottom. What if you didn't have a picture and you just couldn't draw a picture, right? You just couldn't remember how to draw these functions. You're taking a test and you're drawing a blank, right? Okay. All right. So if you're stuck and you don't know what to do, pick a point in between your 2 points of intersection. So pick any x in between here. What's the best one?
0.
0, right? If you pick any x in between your limits, and plug it in, if I plug 0 in here, I get 0. If I plug 0 in here, I get 3. The one that's bigger is the one that's on top.
So we look at the C bottom?
Does that make sense? Okay. So if you're ever not sure, just pick an x value inside of your interval and plug it into both functions to see which one's bigger. And that would be the one on top. Okay. All right. Now, 90% of the time on the AP exam, these problems are calculator, which means you're going to be required to write the full integral setup, and then you could just go to the answer. Okay, so you just put this in your calculator, do that little integral thing, and you get the answer. On your quiz, which is now on Tuesday, your quiz is no calculator, right? So you're going to have to be able to do these by hand. So let's review how to find this antiderivative. So antiderivative of 2x?
X squared.
X squared, it's been a while, plus,
3x.
minus,
1/3 x cubed.
hey, 1/3 x cubed, remember from the joke?
Yeah, can you explain that joke? Because that kind of sucked.
Wow!
get it.
Yeah, I didn't get why it was so funny. Like,
I thought it was funny
I didn't
because
read
you
it.
have this waitress, she doesn't even, can't even doesn't even figure out that they're saying 1/3 x cubed, right? She's sitting there going 1/3 x cubed, right? And but then when she understands the context of the calculus problem, she knows it and zips it off. I thought that was awesome. Come on.
I was really tempted to say that I was offended because it was making fun of blonde people. Because it's like, let me
And
go ask that
waitresses.
blonde waitress.
Yeah, yeah.
It's kind of hurtful.
I guess.
Yeah, it was too long, did not read.
But I think maybe next
So I
time
guess
we could-
it's offensive based on stereotypical assumptions, isn't it? But that is what makes it funny.
Also, it's not that funny. Like,
It's very funny. You're wrong.
I'm sorry,
You're
Miss
just
Price, but
wrong.
Your sense of humor is
Too long, did
quite
not read.
atrocious.
Too long did not read?
I was busy focusing on other problems.
Oh, gosh, such a good joke. I love that joke. You're just wrong.
I'm gonna buy
Okay.
you a joke book, and they're gonna be 100 good jokes, And so those you can use on the math test. And
I bet that joke will be in there.
No,
I'll bet you 100 points on my next test.
he's probably right.
Alright, let's plug in. So you get 9 plus 9 minus 9 minus 1 minus 3 plus 1/3.
Well, that's annoying.
Alright, now technically, on the AP exam, you could leave your answer just like that, right, and on your test. I'm gonna go ahead and simplify those, so you get 9, 1 minus 3 is -2 plus 1/3, so you have -6/3 plus 1/3 is -5/3, so minus -5/3 or plus 5/3. So 27/3 plus 5/3 is 32/3.
Yeah, I'm keeping it that way, because I always have problems simplifying.
Alright, so anyway, so that's that. That's your basic area problem. Alright, let's take it up a notch. Find the area of the region enclosed by the graphs of y equals plus or minus the square root of 2x minus 2 and y equals x minus 5.
Can you show us later how to do it on the calculator?
Yes, we will do that.
Alright.
Yes, very fair question, and yes, we will do calculator stuff today. Alright, so we've got this, plus or minus square root of 2x minus 2 and y equals x minus 5. Hey, is this a function?
No.
Yes?
Maybe.
Don't
No.
discriminate,
No.
Ms. Price.
No,
Don't
there'd
discriminate.
be 2 answers possible.
No.
Correct. If you plug in x values, you can get 2 y values for 1 x value, right? 2 outputs for 1 input is bad. That means not a function. Alright, so let's draw a sketch of what's going on. Now, the square root of 2x minus 2, if you factor a root 2 out, you get root 2 times the square root of x minus 1. Square root of x minus 1 is just root x, the square root function, shifted one place to the right, and then dilated by a factor of root 2. So it's really just your square root function, shifted one place to the right, and then a little bit stretched out. So something like that. Something like that. That would be the positive one. But we also have a negative one, right?
Cool.
So this graph also has to go like that. Then we have to graph the graph of y equals x minus 5, which is just a line with a y-intercept of -5, so it's down here, coming up like that. So we end up with this region. We have a problem. The problem we have is that if we are going to do top minus bottom, there is one clear top, but 2 bottoms. If you look carefully,
Right minus that.
here's the points of intersection, right? But there's more graph to the left of there. So what ends up happening really, and don't draw this because it'll get very messy, but if you split this up vertically like this section of the graph has the green top and the green bottom. This section of the graph has the green top and the orange bottom. When you have 2 different bottoms or 2 different tops, you have to do one of 2 things. The first thing you could do, if you wanted to, is you could split this into 2 separate integrals. So you would do the integral from here to here of positive root 2x minus 2 minus negative root 2x minus 2 plus the integral from here to here of positive root 2x minus 2 minus x minus 5. And that would work, and that would give you the correct answer. Or you could just turn your head and look at it sideways. Because if you look at it sideways, you get one orange top and one green bottom.
Well, which way are you looking at it sideways from?
Always turn to the right, because it's right minus left. Okay? So sometimes it's easier to do a problem in a right minus left form than a top minus bottom. So we're going to do this in a right minus left form. And the way that we're going to do that is we're going to solve each of these functions for x so that they're in terms of y. So I'm going to solve this guy for x. The first thing I'm going to do is square both sides. So I get y squared equals 2x minus 2. Then I'm going to add 2. So I get x is 1/2 the quantity y squared plus 2. Then for this guy, this is pretty simple. Solving for x, you get x equals y plus 5. Now that I have my equations in terms of y, I can do an integral doing right minus left. So I'm going to do the setup without the limits. Let's just do the setup first. So we have the integral of, which function's on the right?
Y plus 5. Y plus 5.
Very good, the y plus 5. And then the quadratic is on the left. And then this would be dy. When you find your limits for a function that you're integrating with respect to y, the limits have to be y values, not x values. All right? So when you find your points of intersection, you want to find the y values of the point of intersection, not the x values. So when we set the functions equal to each other, we want to use the ones that have the y's in them, not the x's. So to find the points of intersection, we do 1/2 times y squared plus 2 equals y plus 5. What would you do first? I would too. Yeah, double both sides, get rid of the half. Y squared plus 2 equals 2y plus 10. And then get everything on one side. So you get y squared equals negative 2y minus 8. Oh, y squared minus 2y minus 8 equals 0. Sorry. Okay, factor. So you get y, 2, 4, plus, minus. So we are going from negative 2 to 4. Now, I'm going to show you how to put this in your calculator. When you're doing your homework tonight, here's what I'm going to look for. I'm going to look for setup and answer. You do not have to anti-differentiate every one of these by hand. If you give me the correct setup and the answer, I'll take it. Just warning you though, on your quiz, you're going to have to anti-differentiate by hand. So let's type this in our calculator. Alright. Okay. So here's the problem. The integral that we wrote is written in terms of y, but your calculator doesn't have a y entry button. Mathematically, analytically, if we put x's in this function instead of y's, would we get the same answer numerically? Yes. So we could put x's in for our y's, we could put q's in for the y's, right? The system, the math doesn't care what letter it is, right? It's the same numerical answer no matter what. Right. So we have x plus 5 minus 0.5 times the quantity x squared plus 2, close parenthesis, close parenthesis. Okay. All right, graph. Here's the other issue. We drew a picture that looks like this. This graph doesn't look anything like that.
Of course not,
Why not?
because it's not that much, it's in a different format.
Exactly. Because if I graphed this graph, this is actually a graph of 3 different equations put together, right? This is positive root 2x minus 2, negative root 2x minus 2, and x minus 5. And if I graphed all of those separately in y1, y2, y3, it would look like this. But when I write it all together as one big equation, the calculator doesn't know to split it into multiple graphs. So it's just going to graph that quadratic, whatever it may be. Numerically, it's fine. Just warning you that when you do your graph on your calculator, it won't look anything like your picture, nor should it.
Area.
You understand? Okay. All right.
Well, the area's gonna be the same, so.
Okay, so how do we find the integral?
Yeah, use the calculator.
Calc menu, so you do, here, I'll write this. Second trace, and we go down to which option?
7.
7. And then what's our lower limit? -2. What's our upper limit? Hey, do you think it's a coincidence that those happen to be the x-intercepts for this function?
Nope.
No. If you do it, if your limits are the points of intersection of the two functions, when you put them together, when you're subtracting one from the other, they will become 0 because the points of intersection should be equal to each other. So when you do one minus the other, it'll end up being 0 and they end up being the x-intercepts when you graph. So if your limits are points of intersection, you'll always have the area of the region bounded by the zeros, the x-intercepts. Okay, so the area is 18. Alright, I'm going to draw your next example over here. Blankify this guy. And then move the camera. Alright.
So you can just keep it. Actually, I'm gonna throw that in next round. Why?
Here we go. No idea where I put my
I
notes.
actually brought 2 new ones.
I have such a good graph. Here it is. Alright.
This one.
That's going to be F. And use green.
That is so pretty. It's like Christmas.
Okay,
Christmas
Here we
was
go.
horrible.
that's A. That's B. This is C. This is D. This is E. This is F. And this is G. You know what, let's use a different function name so we don't get F and G confused. So we'll call this P and Q, all right? So P is the brown function, put it in brown, and Q is the green function, and we're going to do all right, here's what I want you to give me. I want you to write an integral or set of integrals that will give you the area of the shaded region. Take a moment and see if you can figure it out.
Oh, this is complicated. I'm up to the challenge though.
Good.
Don't worry. Don't you worry 1 second, Miss Price. Ace Ventura is on the job. Did you get that reference? Like a 90s TV show. I don't know, you might be too young for that.
Movie with Jim Carrey.
Yeah.
Yeah, that's very, very sweet. How old do you have to be considered middle-aged? Is it truly 50 or is it like,
No, because the life expectancy isn't like 100. So life expectancy for the US is like
It's like 78.
yeah, it's like 78. So probably middle age would probably
39
yeah,
is considered middle-aged?
yeah.
Makes sense?
But I don't know. I feel like it's not.
Maybe it's like mid
when
40s.
it's
I think
I mean,
40s.
middle age would be like when your body starts to deteriorate.
Menopause.
39.
39.
Jesus, life changes.
I feel like it's probably higher than that.
39.
39.
39 is pretty close.
But with healthcare nowadays, we're just gonna start living till like 500 years old. And soon we're gonna be able to put our minds into machines and then we'll just never die. And then, yeah.
Become organic, artificial intelligence.
We're gonna be a Terminator. I wanna be like the one that's the girl, just cause she looks like a lot cooler than like Arnold Schwarzenegger. Or maybe the G2, like the G2000, one that's like liquid metal. Then I would like,
That's the best one.
I'd go through like locks and stuff and then I'd just be like,
walks into a bar.
that'd be awesome.
Alright, so what are the limits? Could you do this with just one integral?
Yes. You just have a long interval.
No.
Yes.
No. The
Yes.
answer is no.
Darn it.
Sorry. And the reason is because you have different tops and different bottoms, right? So what would be the limits of the first integral? A to B of what minus what? P minus Q dx, assuming that the input variable is x. Plus, tell me the limits of the next integral. B to E, we don't have to go B to C, and then C to D, and then D to E? Are you sure?
Yeah.
But the C to D part's below the x-axis. Don't I have to subtract that part?
No.
Miss Price, why do you have to make things so complicated? God.
I don't, it's from B to E.
Score.
Okay, of what minus what?
Q minus P.
Q minus P. Guys, it doesn't matter where the x-axis is, it doesn't matter if part is above and part is below. If the top of your shaded region, it's just top minus bottom, it doesn't matter if it's above, it's below, it's in the middle of the x-axis is completely irrelevant. It's the top of the shaded region minus the bottom of the shaded region. Alright, last one. E to G of P minus Q, top minus bottom. Always top minus bottom. That's really like the rule for life.
Why do you
Okay.
not put
42.
Why do you not put like P of X or Q?
Oh,
of X?
you can, I just was lazy.
Would that be acceptable in the AP exam or?
Yeah, but I would put the of X to be safe. Yeah, I'm being lazy here. Alright, one more problem, and then we're going to talk about what's going to happen next week. So, the last problem I want to do is actually one of your homework problems. I'm going to give you a freebie. By the way, I am aware that I still have not checked section 5.7's homework. So, on Monday, I will check both 7.1 and 5.7, which was the inverse trig integral stuff.
Oh, you mean.
That's like last time.
Alright? That was like a week or two ago.
It was numbers 1 through 41, odd, skip number 7.
Alright, so I let first period choose the problem, and they chose a really good one. So I'm going to do this one again. They picked number 31 out of your homework tonight, and it says f of x is 10 over x, x equals 0, y equals 2, and y equals 10. And the directions are sketch the region bounded by the graphs of the algebraic functions and find the area of that region. So if we sketch the graph, 10 over x, well, 1 over x looks like this. 10 over x would look like that also, just stretched. So it's the same graph. So there's our graph, 10 over x. X equals 0. What is that? Is that the x-axis or the y-axis? Are you sure? I only heard 2 people answer.
Wait, what?
Is x equals 0 the x-axis or the y-axis? It's the y-axis, because x equals number is always a vertical line, right? Okay, so x equals 0 is that line right there. Y equals 2, is that a vertical or horizontal line? That's horizontal through 2, and then y equals 10 is a horizontal line through 10. So this is the region that we are finding the area of.
Wait, how do you know which region? Oh, is it 'cause the only one enclosed?
It's the bounded region, yes. And by the way, if they give you 4 boundaries, 4 functions, then your region has to use all 4 of those as bounds. So sometimes there's multiple enclosed regions, but you have to look for the one that uses all the functions given as your bounded region. All right, so what should we do? I see 2 tops and 1 bottom. What might be the better approach for this?
Left to right.
Let's go do right minus left. We're going to do a
Right
dy.
minus left.
So if this function is actually y equals 10 over x, first thing you have to do is solve it for x. So that's equivalent to x equals 10 over y. So what we have now is x equals 10 over y, x equals 0, y equals 2, and y equals 10. Our area is going to be the integral from what to what?
2 to 10.
2 to 10. So those horizontal lines end up being our limits. What function comes first? What's on the right? 10 over y. Minus, what function's on the left? 0. dy. Now, technically you could use your calculator, but let's just see what you remember from last week. What's the antiderivative of 10 over y?
ln of y.
Yes. 10 ln y
That's what I meant.
from 2 to 10. So you get 10 ln 10 minus 10 ln 2. And you could just leave it like that. By the way, what would be really fun though, would be if you recognize this. Right? Oh, those long properties are so wacky. Okay, all right, so anyway, so let's talk about what's coming up. Closing off the video.